Right, this is now a roots or polynomials question, but involving a bit more algebra. Right, so P is the coefficient of x squared. Now, so we know that the sum of the roots, roots aren't alpha, beta and gamma, for a change there, alpha over k plus alpha plus k times alpha, must be minus b over a, so that's minus p over 2. And then we can rearrange that, so p is multiplied by 2, multiplied by 2 and negative 2, and then we can get alpha over k plus alpha plus k alpha. So that's p. Right, q is the coefficient of x, so that's the sum in pairs we need to look at here. So that's alpha over k times alpha plus alpha over k times k alpha plus alpha k alpha. So that's going to be q over 2. So we can rearrange that to get that q is 2 and do a bit of simplifying as we go. Alpha squared over k plus alpha squared plus k alpha squared. Right, and then finally r. Now r is the product of the roots, so we're just going to multiply those together. That's, sorry, r over 2 gets divided by a. So r is 2 minus, remember, so it goes minus b over a, c over a, minus d over a, they've got negative, so r is negative 2 times alpha cubed. Right, in part B we've got a show that going on here. It looks a bit complicated. It might be useful to have a look back at what we've worked out, and if you see p, we could actually factorise p some more, because we've got alpha in common with all those terms. So let's take alpha out as a factor of p. Okay, and then if you look at q, well, that's got alpha squared as a factor. So let's take alpha squared out as a factor. Now this is going to be quite handy because I can see now that we've got some things in common here, and we've also got a 2 in common. Now this could be quite useful. Right, so what do we want to do? We want to show that 2q cubed equals p cubed r. Right, okay. So let's see what we can do here. So q cubed, okay, let's substitute in a bit. So we want 2 times, now q is 2 alpha squared times 1 over k plus 1 plus, oops, k, all cubed. That's q. P, if I have a look up, for p I had negative 2 alpha times 1 over k plus 1 plus k cubed, and then r is negative 2 alpha cubed. Okay, right, so let's see what's going to go on here. So I've got 2. Now I've got some brackets here, but there's 3 things multiplied in this bracket, and they're all to the power of 3. So that's 2, that 2 is to the power of 3. Now I've got alpha squared to the power of 3, so that's going to be alpha to the power of 6. Remember, power to the power, we'll multiply the powers. Then I'm going to leave this bracket as it is, but that is to the power of 3. On the other side now, I've got negative 2 cubed times alpha cubed times, and then the bracket cubed, okay, and then times negative 2 alpha cubed. Let's see whether we can simplify anything here. So this is now 2 to the power of 4. I've got 2 lots of 2. You can leave that as 2 to the power 4, or you can write that as 16, doesn't matter, or alpha to the 6, 1 over k plus 1 plus k cubed. Now we like leaving things factorised in maths, and that's factorised, so I'm not going to expand all that. I'm going to see what happens now on the other side. So over here, you can see I've got negative 2 cubed times negative 2. So that's negative 2 to the power of 4. That makes it an even power. So that will mean it'll come out as a positive number, which is 16. And if you're not sure, you can try it out in your calculator. I've then got alpha cubed times alpha cubed. So that makes alpha to the 6. 3 plus 3 is 6. And then I've got 1 over k plus 1 plus k cubed. Now, as you can see, those things are exactly the same. So therefore, we've just shown they're exactly the same. So 2q cubed is exactly the same as p cubed r. Right, finally, we're asked to solve the case when p equals q equals minus 3. Okay, so see, we know p equals q equals negative 3. That means we can work out r using our equation up here, because r is 2q cubed divided by p cubed, but p and q are equal, so r is just 2. Right, that means we now know, if we have a look, we can write out what our actual equation is. So that's 2x cubed minus 3x squared minus 3x plus 2 equals 0. Right, it now wants us to solve the equation. Now there's various different ways you could do this. Obviously we could just put it into our calculator, and that will tell us the roots are -1, 2 and a half. So there we go, that's solved straight away. So calculator tells us x is -1, 2 and a half. What about if we actually wanted to work it out and not just rely on the calculator? Well, there's one that's an easy one to start with. Remember back here we found r equals -2 alpha cubed. We know r is 2, so 2 equals -2 alpha cubed. That means alpha cubed is -1, so alpha equals -1. So that's got us alpha, and alpha, remember back here, was one of the roots. Once you've done that, you've got a couple of choices. Right? Now, so there's lots of ways to solve this. One way is we could then find out what k is. So to find out what k is, you've got to use one of the two equations up here, where we had p and q. I don't know if I'm going to be able to copy those down, but they're the ones we would use. Okay? So you'll need to use the fact that p equals -2 alpha over 1 over k plus 1 plus k. We've got q equals 2 alpha squared plus 1 plus k. Okay, and then p and q are both -3, so -3 is -2 times -1, 1 over k plus k, and here -2 equals, so we've got 2 times 1, 1 over k plus 1 plus k. Hope you can see those actually give the same equation. So 3 over 2 equals 1 over k plus 1 plus k. Then you could take the -3 over 2, because it will be -3 divided by 2 in both cases. Move the 1 to the other side. -5 over k is 1 over k plus k. You can then change that, multiply everything by k. Right, so we've got k squared plus 5 over 2 k plus 1 equals 0. This way is actually quite long-winded. You get to k is -1/2 or -2. Once you've done that, you know the roots were alpha, k alpha, alpha divided by k. You can put all the numbers in. It doesn't matter. You don't whether k is -1/2 or -2. You actually end up with the same roots because this is -1, and then k times alpha. Say we took k to be -2. That will give us 2. And in the other case, it would give us 1/2. If you switch those around, so you use -1/2 instead, you just get these two roots the other way around, so you get the same roots. Okay, as I said, that was one way. There is another way. We now know that one of the roots is -1. Now that means that x plus 1 is a factor of this. So that means we can now use division and we can now factorize this. So we know x plus 1 is a factor. We know it's going to have to be 2x squared to make 2x cubed. We've got +2 here, so it must be +2 at the end. And now we just make this balance, so that gives us 2x cubed plus 2x squared. We want -3x squared, so it must be -5x in the middle. And then we can just check that that expands to give the right thing. So that's going to give us -5x squared minus 5x plus 2x. There we go. Once you've done that, we can just then factorize this one. Right? So it must be x there. It's got to be 1 and 2 to get +2. They've both got to be negative because we've got to get a negative there. So it must be -2 times 2x to get -4x and -1 times x. Now we've got it fully factorized. X is -1, 1/2, or 2. You could factorize this any way you like. You can do the long division any way you like.